You're sitting at your desk. You know exactly what you need to do. You actually want to do it. The deadline is real. You understand the consequences, and you cannot move. This isn't laziness. This isn't procrastination in the way most people mean it. This is a specific neurological event, and it has a name: ADHD paralysis. If you've experienced this, you're not alone. Roughly 15.5 million US adults have a current ADHD diagnosis, and research suggests about half were diagnosed after the age of 18, which means a lot of people have been blaming themselves for something that has an actual mechanism. Today, we're going to look at what brain imaging research actually shows is happening in that frozen moment. I'm Spark. Welcome to Spicy Neuroscience. Let's start with what's happening physically. When researchers put people with ADHD into fMRI and functional near-infrared spectroscopy scanners and ask them to perform executive function tasks, things like inhibiting a response, sequencing a plan, or starting a goal-directed action, they see something specific. A 2024 systematic review in the Frontiers Journal family concluded what the field has been converging on for years. The prefrontal cortex in ADHD brains shows measurably reduced activation during executive function tasks, reduced blood flow, reduced glucose metabolism. The region responsible for initiating action is, quite literally, underpowered during the exact moments it's being asked to perform. And it gets more specific. The dorsolateral prefrontal cortex, the part that handles working memory and task sequencing, often has to recruit more effort to achieve the same result a neurotypical brain achieves with less. One 2021 study in Frontiers in Human Neuroscience found that adults with more ADHD symptoms had to activate their right dorsolateral prefrontal cortex more strongly just to perform the same go-no-go task. Let me translate that. Your brain isn't doing less. It's doing more, harder, to get the same output. That's not laziness. That's a system running at 110% to deliver what looks, from the outside, like 60%. And underneath that is the dopamine system. People with ADHD tend to have differences in dopamine transporter activity, the mechanism that regulates how long dopamine stays available in the synapse. The specifics vary by genotype and brain region, but the consistent finding is this: dopamine availability in ADHD brains is different. Not absent, different. And in regions that matter for motivation, reward, and task initiation, that difference shows up as a persistent shortage at the moment you need it most. Now here's where standard advice goes sideways. The most common ADHD productivity advice, the one every article and every well-meaning friend offers, is just break it into smaller steps. Consider what that actually asks of an ADHD brain. Breaking a task into steps is itself an executive function task. It requires planning, sequencing, prioritizing, working memory. Every single one of those functions lives in the prefrontal cortex. The exact system we just established is already working harder, with less available dopamine, in the ADHD brain. So when someone says, just make a list, they're asking your most strained system to do extra work before you can begin the work. They're asking the bottleneck to widen itself. They're asking the sprained ankle to run to the starting line. And the painful irony is this: the more steps you break the task into, the more decision points you've created. Each sub-step requires a micro-decision to initiate it. Each micro-decision demands its own hit of dopamine, the exact resource your brain is already conserving. So the beautifully detailed to-do list doesn't reduce the load, it multiplies it. This is why so many ADHDers have the same devastating pattern. They spend an hour making the perfect plan, feel a rush of relief, then find themselves unable to execute any of it. The plan itself consumed the fuel needed to act. Now, sub-steps aren't universally bad. For some tasks, for some brains, some of the time, they help. But they are not the neurological silver bullet they're sold as. And if they've never worked for you, that's not your failure. That's a mismatch between the advice and the mechanism. There's a second layer to this most people don't know about. And it's one that makes ADHD paralysis feel so physical. You've heard of fight, flight, and freeze, the 3 stress responses. In clinical descriptions of ADHD paralysis, what many researchers describe is essentially the freeze response being triggered by executive overwhelm. Here's how it unfolds. Your prefrontal cortex, already running at high effort, encounters a task that pushes it past capacity. This can happen when something's complex, emotionally charged, or carries real consequences. The planning system glitches, overwhelm registers, and the brain's threat response system interprets the overwhelm in the same way it interprets physical danger. The stress response takes over. Your body doesn't know the difference between tiger in the grass and email from your boss. It just knows overwhelm and anxiety, threat, shutdown, freeze. This is why ADHD paralysis doesn't feel like not wanting to do something. It feels like you've been put in ice. You feel absolutely stuck. You can see the task. You want to do the task. But the system that initiates movement has gone offline because another system has interpreted the situation as a threat and pulled the emergency brake. You may be left confused and even disappointed in yourself. This is also why just push through it is some of the worst advice you can receive in that moment. You can't willpower your way out of a freeze response. You can't reason with your amygdala. The way out isn't more pressure. Pressure is what triggered it. The way out is lowering the threat signal you're experiencing, so your prefrontal cortex can come back online. Which brings us to what actually works. Strategy 1, body doubling. The first strategy is called body doubling. It's often one that surprises people most because it sounds almost too simple, and yet it works on a specific neurological mechanism. Body doubling means performing a task in the presence of another person, either in the same room, on a video call, or even in a focused co-working session online. The other person doesn't help you. They don't talk to you. They're just present, doing their own thing, aware of your shared session. Sounds vaguely familiar, right? Have you ever noticed your ability to focus intensely when others are around you, or when you're at work in the office? The Cleveland Clinic describes body doubling essentially as external executive functioning. This means outsourcing the planning and anchoring functions your prefrontal cortex is struggling to produce internally. A 2024 review found measurable improvements in task initiation for people with ADHD who used it, and a 2025 study in virtual reality environments confirmed that both human and AI body doubles improve task completion speed. Yep, AI body doubles may actually be able to assist with focus, in some cases, of course. Why does it work? Well, actually 2 reasons. First, social presence activates the brain's reward circuitry, including dopamine-releasing pathways, which provides some of the neurochemical fuel the prefrontal cortex is short on. Second, the implicit accountability of being observed engages a different neural pathway than internal self-direction. You don't need to generate the structure yourself. The structure is there, in the form of another person. Here's how you can try it for yourself. Set a 50-minute focused session with a friend on video, join a body doubling community online, or even play a study with me video with a real person working quietly. State your goal out loud at the start. That's the whole intervention. Strategy 2, dopamine priming. The second strategy is dopamine priming. It works by giving your system a small hit of dopamine before a hard task. This makes sure your prefrontal cortex has something to run on. This doesn't mean mindlessly scrolling TikTok for 20 minutes. Scrolling is a dopamine cliff. It spikes, crashes, and leaves you with less baseline reward sensitivity than you first started with. Dopamine priming means short, contained, physically engaging activities that gently lift your dopamine floor. A few examples both research and clinical observation support. 3 to 5 minutes of moderate intensity movement, such as walking, stairs, or even dancing. Try a cold water splash to the face, or maybe a specific song you often associate with previous states of flow. A small, completable task you've already succeeded at might include making the bed, finishing a glass of water, doing the dishes you can see. The structure matters. The instruction you give to yourself must be short, have a clear end, involve your body, and produce a completion signal. Then, immediately, you use that elevated baseline to approach the task that was frozen. You're not trying to force the hard thing. You're changing the neurochemical conditions the hard thing has to happen inside. It's pretty much modern-day biohacking, and we're getting better every day with what we know about the brain and our nervous systems. Strategy 3, the 5-second override. The third strategy is for the exact moment when you're already frozen and you need something to break the pattern right now. I mean, immediately. It's a physical override. It bypasses the prefrontal cortex almost entirely. The version I'll share here is based on a simple principle. The brain struggles to execute abstract commands such as start the task, but it can execute precise physical commands almost without a conscious effort. So if you hand your body a physical command it can't misunderstand, such as stand up, put your feet on the floor, or open the document, not the task itself. Just the next physical motion that precedes the task. This is sort of like breaking down the system. A common version of this is counting down from 5. 5, 4, 3, 2, 1. And on 1, you execute a single physical motion. The countdown disrupts the freeze loop. The physical motion bypasses your original planning system. You're not asking your prefrontal cortex to make the decision anymore. You're actually giving your motor cortex a direct instruction. This isn't some form of magic. And keep in mind, it doesn't work every time. But for many ADHD brains, it's the fastest available override when you're already frozen. Because it doesn't ask the broken tool to fix itself. It routes around it. If you've ever blamed yourself for your brain because it works a bit differently, I hope today's video gave you a bit of an understanding about how ADHD brains actually operate, so you can get unstuck and out of the paralysis loop. Your brain isn't broken. You were just handed the wrong manual. Also, in case you missed it, I'm Spark. Like this video if you found it interesting or informative. Everything helps. Subscribe so you won't miss another spicy neuroscience upload.